And so that's what we set out to do with Hemi. And the way we do that is through something called the hVM, or the Hemi Virtual Machine, which is an EVM, fully EVM backwards compatible. Whatever DApp smart contracts used on Ethereum, they work the same in the hVM. But what we did is we added a Bitcoin full node inside that EVM. And so smart contracts can now talk directly to a deterministic Bitcoin node that's available in the protocol. And so without going too much into some of the finer tech details, the Bitcoin protocol has a lot of limitations in its architecture. And so it's really hard for an application running on Ethereum to see what's happening on Bitcoin in a reliable manner. And there's been approaches over the last 10 years that do little pieces of it with things like header relay systems, or having an oracle for some data from Bitcoin that you're trusting. But you're either limited in what you can see on Bitcoin, or you're limited in the trust models and trust assumptions that you're introducing into your application. And so when we designed hVM, we said, what's the most trustless, deep knowledge of Bitcoin that we can bring into a programmable environment like an EVM? How do we do that? And the answer was build a custom Bitcoin full node that lives directly inside the EVM that smart contracts can talk directly to, and then build a network that basically combines Bitcoin and Ethereum. So when you look at a lot of L2s, your Optimisms, Arbitrums, ZK Syncs, they're single chain L2s. So they're an L2 to just one L1, which is Ethereum. Then you have L2s in the Bitcoin ecosystem that are L2s just to Bitcoin. And what we said is we want all the features of Ethereum, but we also want the user base, the dApps, the liquidity of Ethereum,